Dear students, in this video lecture, we are going to discuss about carrier sense multiple access, collision detection and collision avoidance techniques. The previous video, we have discussed about carrier sense multiple access, how it is working, what are the persistence methods are there, how it is working, and what is aloha, what is pure aloha, what is slatter aloha. Those things we have discussed in the previous video lecture. In this video lecture, we are going to discuss about carrier sense multiple access method with collision detection or collision avoidance. Okay. So in this video is classroom discussion topic 23. Okay. So week 8 lecture 2 video, we are going to discuss about CSMA CD, CSMA CA. So before going to discuss about these topics, we know we have to discuss about outcome. What is the outcome? After completion of this lecture, students will be able to detect the collision if it is occurs while transmission, while data transmission in the carrier. Using the carrier sense multiple access collision detection method, you are able to detect there is a collision occurred or not. How to avoid the collision? So this is the outcome of this lecture. So first we are going to discuss about carrier sense multiple access collision detection techniques. What is carrier sense multiple access? Carrier means that's a transmission medium. We have to sense. V means that the session will sense the medium when session is free or not, or it is busy or not. While doing this operation, some collision may be occur. Okay. So this for especially CSMA CD is used to detect the collision using algorithm okay, to handle the collision. What it will do in this method? Session monitor the medium after it sends a frame to see if the transmission was successful. If so, the session is finished. Okay. So what happened? Session is connected with some transmission medium, that is the carrier. This carrier will transmit the data. So what it will do? It will monitor once the session is send the data. This is the session 1. It wants to send to somebody. So in this method, what it will do? It will monitor the sense entire medium. So the data frames are reached successfully or not. If successful means no problem. Okay. If not, what happened? So if not means automatically we know there is a collision is there. If collision occur means what will do? So the frame may be destroyed. So we have to resend the frame. Okay. So for better understanding CSMACD, let us look at the first bit transmission. Okay. So why? Because if two sessions are there, okay. If two sessions are there, here one session is there. This is the medium. Okay. So this session is sending the data here. So this session is sending the data here. So when the first bit is meeting there, there is a collision will be occurred. Okay. So we have to monitor the first bits transmitted by the two sessions involved in the collision. Okay. Although each session continues to send bits in the frame until it detects the collision, we show what happens in the first bit collide. Okay. If there is no collision means all the session can transmit the data without problem. Okay. This is the diagrammatic representation for collision occurrence. Okay, you just see here transmission time of A. Okay, node A transmission time T1. It is transmit the first bit of A. Okay, so the first bit is coming like this. Okay, but what happened here? Again, C also transmit the data. What time it is transmit? So this time T2 it is transmitted for 2 node A to node D. Okay. So what happened? while it is transmitting to the forward direction, there is no collision. But in the reverse direction, this data, when the first bit is meet here, the collision may occur. Okay. Okay. So within the time limit, it's getting the first bit of C, then automatically it knows that collision may be occurred. Okay. So for that, how to identify that, or how to solve that problem? For CSMA CD to work, we need to restriction on the frame size. Okay. So how it will identify the frame size? Minimum frame size. This is the first option we have to choose for avoiding the collision or direct the collision. Before sending the last bit of the frame, the sending station must detect a collision if any and abort the transmission. So in this previous diagram we seen, no, so it's sending the data, it's waiting for acknowledgement. It is reaching here only, but within that particular time, it is getting another bit in the reverse direction. So it is identified that collision may be occurred. If it is occurred, what it will do? It will abort the transmission. So this is so because the session, once the entire frame is sent, does not keep a copy of the frame and does not monitor the line for the collision direction. Okay. So once it is, the session will send the frames, it have to wait. There is the frames are successfully reached here or not. Okay. So the frames are coming. Once it is reached, last bit of the frame is reached destination, then this particular session no need to keep the copy of the entire frame. Okay, no need to monitor also. So that means the entire frame is reached to the destination. So for that, the frame transmission time TFR, okay, just remind, frame transmission time must be at least 2 times the maximum propagation time. Okay, so 2 times means 2 into maximum propagation time. So what they are saying, that must be at least, okay, so TFR equal to the time of transmission propagation time. Okay, so see here, this is the data, first data transmitted time. So this much time it will take. So the last bit transmission is started from here. So when the last bit is transmit, in between it is getting the another frame. So the collision may be occurred here. So automatically it will detect the collision and abort the data. So see this flow diagram here. You can easily identify that with CSMA CD technique. Initially the K value is 0. K means number of attempts. So initially there is no attempt. The session has the frame to send. Apply one of the persistent method. We have 3 methods we know: one persistent, non-persistent, and P persistent. We know these 3 techniques. We can apply any one of the techniques. So in case we are taking one persistent, means if system is ideal and the medium is ideal, means it will transmit the data. So once eligible for transmission, it is transmission eligible, then what it will do? Transmission done or collision detected. We have to wait for any one of the status. Transmission done means what it will do? If transmission done means, here transmit the data and receive the data continuously. There is no problem. Okay. So in case collision detection has occurred, if occurred yes means, then it will identify that collision is detected. Okay. If collision detected means, send a jamming signal and try for next time K value equal to K plus 1. Next time resend the frame. How much time we will fix it? Maximum 15 times. Okay. So already we know the CSMA process. Okay. So that we are using it. Back of time, average transmission time, that everything it will be applicable here. But if it is no collision detector means the frame is successfully received. Okay. So if more than 15 times, if it happened means they abort the transmission. Okay. So this is the reflections part. You have time to answer the question. CSMA CD, the frame transmission time TFR must be double the propagation time, equal the propagation time, thrice the propagation time. What is your answer? The time over. The answer is double the propagation time. So two time of propagation we need once the packet is our frames are reached. That means last bit is reached to destination or not. For that we need 2 times of propagation time. Now we are going to discuss about CSMA CA method, carrier sense multiple access collision avoidance techniques. The technique is collision detection technique. This technique is collision avoidance technique. Okay, so what it will do here? The basic idea behind the CSMA CD is that session needs to be able to receive while transmitting to detect a collision. Okay, in CSMA CD means it will identify collision is occurred or not. Okay, when there is no collision means session receives one signal, its own signal. Okay, when there is a collision, session receives two signal. So in this previous diagram we seen no. So within the transmission time, the first signal is transmitted within the time. So there is no collision. If within the time limit, if any other frames are coming, then we can say collision may be occurred there. Okay. So to distinguish between these two cases, the received signal in these two cases must be significantly different. Okay. In other words, the signal from the second session needs to add a significant amount of energy to the one created by the first session. How to avoid the detect collision? So for that, if that means the collision, the detected energy at most doubles. So what they are saying that in wired network, the received signal has almost the same energy as the sent signal because either the length of the cable is short or there are repeaters that amplify the energy between the sender and receiver. Okay. In wired network, what we are doing it? We are using the repeater for amplifying the signal. Okay. Otherwise, if shortest length means the no energy loss is very less. Okay. In this situation, we can identify if there is the energy is more, then we can say that collision may be occurred. Okay. In this situation, we need to avoid collision on wireless network because they cannot be detected. In wired network, we know the energy of the signal. If the energy of the signal is double the signal means automatically we know collision is avoided. We can avoid that signal. But in wireless network, we are unable to identify. Okay, so for that purpose only, it is invented CSMA-CA technique. So what are the techniques are there? Three techniques are there. One is interframe space. Second one is contention window. Third one is acknowledgement. These three techniques is used for avoiding collision. Okay, first one is interframe space. What is interframe space? So first one, collision are avoided by differing transmission even if the channel is found ideal. Okay. When an ideal channel is found, the session does not send immediately. So what is the IFS? First, collisions are avoided by differing transmission even if the channel is found ideal. Okay. So channel is there, systems are connected. So even when the collision will be occurred, if the channel is free, that is ideal. Okay. So then all the session try to send the data. So then the collision may be occurred. Okay. When ideal channel is found, the session does not send immediately. So what the first rule is they are saying? They are saying that don't send immediate data, even the medium is idle. It will wait for a period of time called interframe space. Okay. So we have to allocate some time that for that time the particular session will wait the particular time. That time is considered as interframe space. Okay. Even though the channel may appear ideal when it is sensed, a distance session may have already started transmitting. Okay. So interframe space is there, no? So what happened? I already told. So this is the medium is there. So first session here it is there. So this is the last session. So it will check, it will transmit the data, but it is not receiving the first bit of the particular frame. So what it will do? The session is free. It's ideal. Like that it will think. But in case if it is there, the session should wait. Why? Because interframe time is allocated. The particular time is happened means it should wait. It's not send immediately. Why? Because the other session maybe start the transmission. So interframe time allows the friend of the transmitted signal by the distance session to reach this session. If the interframe time, the channel is still idle, okay, the session can send, but it still needs to wait a time equal to the contention time. Okay, so interframe time should be there. Till that time, it will have to wait. Once the reach the interframe time, even it's still ideal, the session will wait for some equal time of contention time. What is contention time? That we will discuss in the further slides. So interframe interframe space variable can also be used to prioritize sessions or frame types. For example, a session that is assigned a shorter IFS has highest priority. Okay. So what is the interframe time? It is some random waiting time. Okay. So session 1, session 2, session 3 is there. So these sessions are connected with the common medium. Okay. So there is a IFS time is there, interframe space time. So each session have that IFS time is there. Why? Because if session is ideal, don't send the data. You have to wait for this time. So this time is very less for prioritized sessions. So we are given most priority for this session means it's have less time. So it's have the second priority how this session means it's have medium interframe time. This is no priority means it may be sent last. Okay, so we can give the priority according to the IFS space. IFS time. The second method is contention window. What is contention window? So the amount of time divided into slats. Okay. So slatted alpha we know that no. So like that, the entire time will be divided into slats. A session that is ready to send, choose a random number of slots as its wait time. Okay. So the time will be splitted into slices. So each session will take random slices. According to the slices, it have to wait for transmit the signal. The number of slots in the window changes according to the binary exponential backoff strategy. Okay. Exponential values, binary values, exponential values it will take. Okay. So this means that it is set one slot the first time and then double each times the session cannot detect an ideal channel after the ABS time. So what happen if we have the priority? Okay. So it will take the time and it have to wait. So already we are saying time slots are there. First time it will take and it will wait. second time it comes, again it will, medium is busy, then it will take second slot. So again it have to wait. Like that it is waiting. So it will have again problem for the particular session. That's why it will take IFS time. Okay. So how it will work? It is working based on the P persistence method. What is the P persistence method? It's a combination of one persistent and non-persistent method. Okay. If medium is free, then channel will send the information. Otherwise, it will take the slot random number and it will have to wait for transmitting the frames. Okay. So what happened? One interesting point in this condension window is it will take the time slot. It have to wait. Again, it have to sense the medium. The medium is free or not. Okay. So once time slot over, again you have to sense the medium. If again medium is busy, it will take another slot. You have to wait. Okay. This does not restart the process. It just stops the timer and restart it when the channel is sensed is ideal. Okay. So give priority to the session when it's longest waiting time. So what happened? I already told no. So this is the medium. This is connected. If in case this system have taking slots, first slot it is waiting. Then again it is busy. Second slot it is taking like that. It is taking more slot and then means it's wait long time. So we have to avoid those things. Then we will give some priority for this system also. The last method is acknowledgement. What is acknowledgement? With all these precautions, there still may be a collision resulting in the destroyed data. Even we are doing the contention window or interframe space, still collision may be occurred. Okay. So for that, another method is we need acknowledgements. Whenever we are getting positive acknowledgement, and timeout timer can help guarantee that the receiver has received the frame. So the sender is sending the data that frames. So even it will use interframe space as well as condension window. So some collision may be occurred. So when it will be identified there is no collision. So when it is getting the acknowledgement of the data, then only it knows that there is no collision will be occurred. This is the flow diagram for CSMA CA. So what it is doing, initially it will take any one of the persistent method. It will check channel is ideal or not. If it is ideal, then wait for IFS time. It will take the IFS interference space time. Then it will check the medium. Still ideal is there means it will choose the random time. Okay. So like contention window. Okay. So it will take some contention slot time slot and it will wait R slots. How many slots are there? It will take some slots and it have to wait. After that, it will send the frame till wait timeout. Once timeout, it will check acknowledgement received or not. If received means it is success. If it is not received means it will try again. Okay. So it will check, it will try up to 15 times. Even 15 times it is not successful, then it will be aborted. Or otherwise, it will check again medium is ideal or not. Okay. So now we are in the end of this lecture. I have completed this discussion on random access methods. Now students should be able to detect the collision if it is occurred while transmission. So data transmission starts when the collision is occurred, how to avoid the collisions, what are the methods we are used for avoid the collision. Those things we are discussed in this lecture. Okay. So here again the random access method is there. The problem is just to think about it. Propagation delay is 12 microseconds. Frame transmission time is 8 microseconds. Okay. So what is the first bit to take to reach the destination? How much time it will take? And how much time it will take for last bit to reach the destination? Okay. So here, so example, we will take the propagation time. The propagation time is 12 microsecond means the first bit will take 12 microseconds. Okay. So after reaching this means then the entire frame it will take how much time? 8 microseconds. Okay. So 12 microseconds plus 8 microseconds, totally 20 microseconds it will take for last bit to reach the destination. These are the sample questions for our discussion. How to avoid the collision. Okay. So we can use collision avoidance techniques, interframes, contention window acknowledgements. Okay. And list the channelization protocols. Okay. So what is channelization? What are the protocols are? You just think about it. And draw the flow diagram of CSMAC. So now we discuss finally that flow diagram. You try it yourself. For further readings, you just read random access method as well as you refer the weekly tutorials. Okay. I hope you understood how the CSMA pollution detection techniques and pollution avoidance techniques are working. Okay, thank you very much. I hope you are enjoyed this video. So if you have doubt, you comment ask me. We will discuss in the classroom discussion. Okay, thank you very much.